video, we learned about the embedding layer. Embedding layer converts each and every token into vector, where the vector size is a hyperparameter and it is decided by the developer. And the vector values are learned in the process of backpropagation, right? These vector values are randomly initialized, and after that, these values are learned in the process of backpropagation. And hence, these vector represents more accurate representation of the tokens. Now, this represents one single document, and you can see that this single document is in the form of 2 dimension. It's a 2 dimensional array. Now we have to pass this data to the dense layer, right? To the fully connected neural network. But this fully connected neural network is only capable of, it can only take data in single dimension, right? It can only take the data in a single dimension. And hence, we have to convert this 2D data into a single dimension. And for that purpose, what we do is we make use of a flatten layer. Okay, we will actually make use of a flatten layer. So the flatten layer will convert this 2D data into one dimension, and then it will pass it to the fully connected, or you can say the dense neural network. So how the flatten layer will convert this 2D data into 1D. So basically, this is how your data will look like. So now you don't have these internal brackets here. It's all, it is just a single vector. Okay, you don't have these internal brackets here, and it all becomes a single vector. This is what is done by the flatten layer. It converts the 2D vector, the 2 dimensional document, into a single dimension. And once it is converted into a single dimension, it is passed to the dense neural network. So that is the rule of flatten layer. And after that, as usual, the dense layer will, in the dense layer, uh, your regular learning will happen and you will get your output. Okay, so that's all from the flatten layer. Now we'll see more in the next video.